excuse me, we're going to look at some of the table probabilities in this video. This is question number 10. We're going to look at 10, 11, 12, and all of those kind of have tables either in there or you need to build a table. Alright, so the following data summarizes results from 932 pedestrian deaths that were caused by accidents. If one of the pedestrian deaths is randomly selected, find the probability the pedestrian was intoxicated, or an or probability, or the driver was intoxicated. Alright, now remember, if it's got this little thing right here, we can take the table into Excel, which I'm going to do because we need some totals, because they're not giving us any totals. So I'm going to open up Excel, and I'm going to paste this thing into Excel. Alright, so I'm going to move these over so we can see what it said. So this is the way basically the table looks in Excel. And what you have to understand is the driver's intoxicated and the pedestrian's intoxicated for this cell. The driver's not intoxicated, the pedestrian's not intoxicated for this cell. Alright, pedestrian's not, driver is for this one. The pedestrian's not, the driver's not for this one. Alright, now I'm just going to sum these because we're going to need them for the answers that we're going to be doing. Alright, and then add these together. Oops, Control Z, I didn't like that. Alright, and then this equals this. Alright, so this is our total sum. There's 932 in there. I think they tell us that. Yeah, 932. Alright, so I'm going to write in here that this is the totals. And then this is their totals, because this is how I normally do my tables. But what you have to understand is this 321 means there were a total of 321 pedestrians intoxicated. There were a total of 611 pedestrians that were not intoxicated that were killed in these accidents. Alright, and then remember, these 555 is of these 611 that were intoxicated, or sorry, not intoxicated. These are the 555 times that the driver was also not intoxicated. Okay, so these totals literally mean the total of this column, the total of this column, the total of this row, the total of this row. All right, and then this always is the total of everything, of all the people involved, or all things, whatever the subjects are. All right, and then back to the problem. It says determine the probability a pedestrian or a driver were intoxicated. All right, probability pedestrian or a driver is intoxicated. Alright, remember this is a or problem, so the probability of A or B equals the probability of A plus the probability of B minus the probability of both A and B. Alright, so what does that mean in this context? It means pedestrian is the first one, that's like the A. The probability, it's a pedestrian. Pedestrian is intoxicated. Alright, so the probability of pedestrian is intoxicated plus the probability a driver is intoxicated minus the probability that both are intoxicated. Alright, the pedestrian is intoxicated, the driver is intoxicated, minus they're both intoxicated. So the probability the pedestrian is intoxicated, here's the pedestrian is intoxicated. The probability is equal to how many total were intoxicated divided by the overall total. So 321 over 932. Now it's going to give me a decimal form, but that's where that's coming from. 321 over 932. Alright, the driver is intoxicated. Alright, the driver is intoxicated. The total is what we need here. So I'm going to do 117 over 932. Alright, and then both are intoxicated. For them to both be intoxicated, the driver has to be intoxicated, which is everything in this row. And I'm going to shade that red. And the pedestrian has to be intoxicated, which is everything in this column. And I would shade that, let's say, yellow. Alright, and if this is red and this is yellow, then this would be orange. Well, let's make it a little bit more orange. Orange. Alright, so these 61 is where the driver's intoxicated and the pedestrian's intoxicated. So that means that that piece right there is 61 out of all 932. Alright, now what do? We add these two together, this and this, and we subtract this. So equals this plus this minus this. And there's our answer. 0.404506. Alright, and then they want, don't round to the final answer, they round to 3 decimal places. So 0.405. Alright, now if you wanted to, instead of doing it like I did it, just use the numbers themselves. Let me clear all that out. Take the fill away. Again, if we're using this rule, A or B's probability of A plus the probability of B minus the probability they both happen. So the pedestrian is intoxicated plus the driver is intoxicated minus they're both intoxicated. You could also just say parentheses, the driver is intoxicated, it starts off with pedestrian is intoxicated. So that's the total down here, 321, plus the driver is intoxicated. That's all 117 of these. This minus they're both intoxicated. That's the 61 here. And then put all of that over 932. Alright, then that's giving us the same thing. It's just kind of doing it in one operation instead of 4 different ones all at once. And again, you can also just do the fractions themselves instead of all these different cells. You could just say 321 divided by 932 plus 117 divided by 932 minus 61 divided by 932. Alright, so it just depends on your Excel comfort level if you're going to do it the way I did it here with the cell names, or the way I did it here with the numbers individually, and then adding them together and subtracting the cells. It's just all your comfort level. But the main point is you're using this formula, this OR formula here. Okay. Alright, so we got that one. That was 10. 11's another table, except it's not giving you the table. So I'm going to clear all this out since we got that problem done now. But I'm going to go back and make a new one. Alright, we got 142 subjects with positive test results, 30 false positive results. Among 158 negatives, there are 5 negative results. Alright, and this is people who use marijuana or didn't use marijuana. Alright, so think about how you do this. To get a false positive, it means that you tested positive that you use marijuana and you never used it before. To get a false negative, it means that you did use marijuana and you or you smoked marijuana, you took your test, it did not show that you used marijuana. Alright, so it didn't pick up on that you used it. So what do we need in our table? We need used marijuana, didn't use marijuana, alright, and then up here we got our test results. Positive test result, meaning that it detected, or it showed that we did use it, and then a negative test result shows that we didn't use it. Alright, now just like before with all these tables, a lot of times they'll leave off the totals because you got to have a little something for you to do. So if the totals are left off, you're going to need them, so go ahead and put them out there. Now what you have to understand in this problem is, among 142 subjects with positive test results, this is not where the 142 goes. Right? This is the 142 that had a positive test result that used marijuana. Okay? That's not where the 142 goes. It goes down here with the totals. There was a total of 142 positive test results. Alright? And then it says 310 were false positive. So out of these 142 that got a positive test, the false positives were the ones that didn't use marijuana. Alright, so 30 false positives. Among 158 negative results, so that means negative results, there was 158. Five were false negatives. So I used marijuana, it said I didn't. That's a false negative. Alright, now remember, these other cells all come from addition, and then so that means these cells can come from subtraction. This is equal to 142 minus 30. This one's equal to 158 minus the 5 above it. Alright, everything in these tables comes from just addition and subtraction. Used marijuana is 112 plus 5. Didn't use it is 30 plus 153. Alright, and then your total is, you can either add the 117 and the 183, or you can add the 142 and the 158. Okay, these two things have to add to this number, and these two things have to add to this number. Alright, so these total columns and total rows here are really important, so make sure that you're finding those. Alright, now what's the probability a randomly selected subject tested negative or did not use marijuana? So once again, we got to use the or rule. Probability I test negative or didn't use, that equals the probability I test negative plus probability I didn't use minus the probability I tested negative and didn't use. Alright, so probability I test negative. Oops. Probability I test negative are these 158 divided by the 300. Alright, plus the probability I didn't use marijuana. There's 183 out of the 300. Minus the probability I tested negative and I didn't use. So minus I tested negative and I didn't use. That's these 153 out of the 300. So there's our probability, 0.62666, or to three places, 0.627.